Greetings everyone and welcome to the third video in this 10 video series. My name is Vyom Khanna and I'm delighted to be with you. In the previous video, I hope you learned a great deal about the Internet of Things and its relation to your daily lives. Over the following 10 videos, we will delve deep into concepts like Arduino syntax, soldering, Node MCU, and real-life applications. Today, we are on the third video in this series, so let's keep pushing for success. This video will delve deep into how you can write Arduino code and what that code means from a practical standpoint. We explored the anatomy of microcontrollers and we ended the last video with a discussion on the hardware of an Arduino Uno. You may remember the word IDE as one of the most important things you need to know to write Arduino code. This video will showcase how you can exploit the Arduino IDE to write fantastic and exciting code, so let's get onwards right away. Before further discussing the Arduino IDE, you should know in general terms what an IDE actually is. It's possible you've heard this before in a computer class, but in general terms, an IDE, full form Integrated Development Environment, is software for building projects that combine common developer tools into a single graphical user interface. In simple words, it contains all that you need in order to build amazing projects with the help of code. Without an IDE, a developer must select, deploy, integrate, and manage all of these tools separately. An IDE brings many of those development-related tools together as a single framework. The integrated toolset is designed to simplify software development and can actually identify and minimize coding mistakes and typos. Trust me, it works like magic. An IDE typically contains a code editor, a compiler or an interpreter, and a debugger, accessed through a single graphical user interface. The user writes and edits source code in the code editor. The compiler translates the source code into a readable language that is executable for a computer, and the debugger tests the software to solve any issues or bugs. These are the main components of an IDE, so make sure you know your way around them, even if you're blindfolded. Knowing what each main component does is essential if you want to expand your knowledge in the fields of computer science. Now, let's move on to some of the secondary features of IDEs that may sound insignificant but are truly the real deal when it comes to making your coding life easier. Some of these secondary features are programmable editors, data modeling, unit testing, source code libraries, and automation tools. It is through these tools that an IDE can improve the productivity of software developers due to their fast setup and standardization across all their tools. Without an IDE, developers spend time deciding, configuring, and learning what tools to use for various tasks. Many, or even all of the necessary developer testing tools are included in the integrated development environment. You will only realize the true value of an IDE when you spend significant time using it and getting acquainted with its various powerful features. So make sure you gain tons of experience with IDEs and coding in general. It would really help you to build a base to develop even more powerful projects. Hopefully, all these technical keywords and jargons give you a concrete understanding of what the Arduino IDE actually is and how it is beneficial for the user. So without further ado, let's jump right into the application and see what it's all about. Look at the above picture carefully and pay a great deal of attention. This is what the home page of the Arduino IDE actually looks like. As you can see, the main components of the screen have been labeled for your convenience. Make sure you remember where everything is, because we are now going to examine each one carefully. Firstly, there is a rectangular toolbar which is located at the top of the screen. This toolbar has various features, in other words, circular icons which have their own distinct function. The icons displayed on the toolbar are, from left to right, New, Open, Save, Upload, and Verify. This diagram should help you gain a better understanding of the icons. Obviously, All of these icons are absolutely essential for the proper functioning of the IDE, but one stands out in particular. It is the upload button. The upload button compiles and runs our code written on the screen. It further uploads the code to the connected board. Before uploading the sketch, we need to make sure that the correct board and ports are selected. So, in simple words, it basically transfers or uploads the code from the computer to the Arduino Uno. For this purpose, we need a USB connection to connect the board and the computer. Once all the above measures are done, we can click on the upload button present on the toolbar and the code will be sent. Thankfully, the latest Arduino boards can be reset automatically before beginning with a new upload. If an upload fails, a red message will be displayed in the error window. We do not need any external software to upload our code. Only the board, the computer, and a wire are necessary. Next comes the open button. The open button is used to open the already created file. The selected file will be opened in the current window. It is quite self-explanatory and works just like any other text editing software. The new and save buttons also do exactly what you think they do, so there's no need to waste any time on them. One button that is important though is the verify button. The verify button is used to check the compilation error of the sketch or the written code. Basically, it turns on the compiler, which we've mentioned previously, to check the written code for syntax errors. It checks if there is any language the computer doesn't understand, which is outside the rules of coding language. If it finds such language, it prints a red error message. These errors must be removed, or the program will not be able to be uploaded onto an Arduino board. Next, there is the serial monitor. The serial monitor button is present on the right corner of the toolbar. It opens the serial monitor, which is like a screen that shows all of your program's virtual output. So, if you ask your program to display the temperature from a sensor on the screen, it will do so on the serial monitor. The icon is shown just below, and make sure you pay attention because you'll be using this a lot. When we connect to the serial monitor, the board will automatically reset. If we want to process the control characters in our sketch, we need to use an external terminal program. These external programs should be connected to the COM port, which will be assigned when we connect the board to the computer. More about this in the future as we progress through the course. For now, just make sure you know the definitions. Next comes the menu bar, and just like it is on Google Docs or Microsoft Word, it is located above the toolbar. This menu bar has various individual drop-down lists, which we will examine in this section. When we click on the File button on the menu bar, a drop-down list will appear. It is shown below. Firstly, let's talk about the New button. Naturally, it opens a new window. It doesn't remove the page which is already present, and although it can be helpful at times, it's nothing special. Next, the Open button. It allows us to open various stored sketches or simply pages of code which can be browsed from the folders and computer drives. Then, the Open Recent button. It contains the list of the recent sketches, because sometimes browsing through computer files to find one program can become quite tedious, so this button just makes our lives easier and faster. Then, there's the Sketchbook. It stores the current sketches created in the Arduino IDE software. It opens the selected sketch, or just simply the page of code, in a text editor at any instance. Then, there is the Examples button. This is arguably the coolest and most useful button on the entire IDE. It shows the different examples of small projects for a better understanding of the IDE and the board. The Integrated Development Environment provides examples of self-practice, whether it is blinking LEDs, displaying information on an LCD, or using various sensors. There are numerous examples showcased on this IDE. All you have to do is click it and select whichever one you would like. Even better, it allows you to copy-paste and even straight up use the code from the example without altering it. You should really be able to explore deep into this button in your own time. It will provide you with a wealth of knowledge. Next, there is the close button, which simply closes the window from which the button is clicked. The save button is used to save the current sketch. It also saves the changes made to the current sketch. If we have not specified the name of the file, it will open the Save As window. Then, lastly, we have page setup. It allows us to set the page margins, orientation, and size for printing. The page setup window will appear as follows. It's not really used ever, but if you are particular about formatting, you should take a note about this feature. Moving on, there is the print button. According to the settings specified in page setup, it prepares the current sketch for printing. This basically means that we are running the code which we have written, and an output will be generated on the serial monitor or any other designated location. Then there is the quit button. It's used to close all of the IDE windows. The same closed sketch will be reopened when we will open the Arduino IDE. So hopefully, you shouldn't be losing any progress when you quit the IDE. The remaining buttons in this section have been left out as they hardly have any use, and their purpose has been covered in some form or the other using the buttons that we have already discussed. So don't worry, you haven't missed out on anything important. The next main section is the Tools section. This contains many of the icons which you will come across in your day-to-day coding lives. So make sure you know your way around each one of them. When we click on the Tools button on the menu bar, a drop-down list appears. It's shown below. Take a minute to ponder this list. Now, let's discuss each option in detail. Firstly, there is the Auto Format. The Auto Format button is used to format the written code. For example, lining the open and closed curly brackets in the code. This is an incredibly powerful feature for coders because the orientation of the curly brackets, the line spacing, and the indentations play a major role in the readability of your code. Moving on, we have the Archive Sketch button. On clicking this, a copy of the current sketch or code is archived in the .zip format. The directory of the archived sketch is same as the original one. Then, we have the Manage Libraries button. It shows the updated list of all the installed libraries. We can also use this option to install a new library into the Arduino IDE. If you did not already know from other spheres of coding, libraries are basically folders of source code that provide some additional special functionality to your IDE. For example, some libraries may contain commands which act as shortcuts to work with sensors or even send data. Then, there is the Serial Plotter. The Serial Plotter button is used to display the serial data in a plot. It comes pre-installed in the Arduino IDE. Think of it as a serial monitor only, but solely for the listing and plotting of data, like a graph. Then, we have the Wi-Fi 101 firmware updater. It is used to check and update the Wi-Fi firmware of the connected board. You need to make sure all your software has been updated, because inconsistencies in the versions of software and hardware can cause problems that can be incredibly difficult to diagnose. Then, there is the Board button. We are required to select the board from the list of boards. The selected board must be the one which is actually connected to the computer. There are pretty large amount of options for each Arduino board, so yours will 100% be on the list. This option actually exists because each board may have different data transfer protocols, pins, specifications, and anatomy. So one line of code for one board does not translate to the same effect on another board. Now, we have the port button. It consists of the virtual and real serial devices present on our machine. It basically just shows which devices are connected to your computer system. Now, we have the Get Board Info button. It gives us information about the selected board. We need to select the appropriate port before getting information about the board. Otherwise, there will be a mismatch and an error will be generated. Next, we have the Programmer button. We need to select the hardware programmer while programming the board. It is required when we are not using the onboard USB serial connection. It is also required during the burning of the bootloader. This is something you should know by definition, but not necessarily concern yourself with, as it is not too important right now. It's more of an advanced concept and relatively niche. It's the same story with the Burn Bootloader button. The bootloader is present on the board onto the microcontroller. The option is useful when we have purchased the microcontroller without the bootloader. Before burning the bootloader, we need to make sure about the correct selected board and port. But don't worry, this shouldn't be an issue with the Arduino Uno, as both the board and the bootloader are present. Finally, we move on to the last section we will discuss today, the help section. When we click on the help button on the menu bar, a drop-down list will appear. It's shown below. Take a minute to ponder, as it is quite useful. The help section includes several documents that are easy to access, which come along with the Arduino IDE. It consists of a number of options, such as getting started, environment, troubleshooting, reference, etc. We can also consider the image shown above, which includes all the options under the help section. Some documents, like getting started, reference, etc., can be accessed even without an internet connection. But when we do have internet connection, it directly links us to Arduino's official website. By now, I hope you've got a concrete understanding of the intricacies of the Arduino IDE. Make sure you revise every concept thoroughly, because you will be using it almost all the time. That's enough tech knowledge for one day. We really condensed a lot of concepts into this one video. Be sure to join me in the next video of the series, in which we explore Arduino coding rules through various examples. Until next time, bye-bye.